Hey friends, this is Jim here at Science Talk. Want to share with you kind of an interesting new study that's come out. So let's take a look at it. And it was published on ARCIS website, which is the Arctic Research Consortium of the United States. Nice little acronym. Paleoclimate Project shows Arctic temperatures and ecosystems highly sensitive to carbon dioxide levels. A recent study indicates that ground surface temperatures in the Arctic may be more sensitive to the level of CO2 than previously thought, using three independent proxy temperature records from an early Pliocene peat deposit in the Canadian High Arctic. Investigators estimate that mean annual temperatures of the Paleoarctic environment was 19 degrees Celsius warmer than today. While Arctic temperatures were significantly warmer during the Pliocene, CO2 levels were only slightly higher than at present. These findings indicate that Arctic temperatures are highly sensitive to greenhouse gases. Now, let's highlight that statement. These findings indicate that Arctic temperatures are highly sensitive to greenhouse gases. This could explain in part why the Arctic is warming at a considerably higher, faster rate than the rest of the planet. Now, 4 times faster than the rest of the planet. Led by a team from the University of Colorado Boulder and principal investigator Ashley Ballantyne, Department of Geological Sciences, this international project sought to develop robust proxy temperature indicators from the Pliocene epoch. Now, the Pliocene epoch occurred from 2.6 to 5.3 million years ago. And that is the most recent interval in Earth's history when CO2 levels were comparable to those of today. Now, the epoch that followed the Pliocene, so when 5.3, it ended about 2.6 million years ago. So from about 2.6 million years ago to ending about 11,700 years ago is the Pleistocene epoch, where we see these ice ages. So in other words, for the Pliocene, the planet was cooling down, and it cooled down to very low levels, where the CO2 is probably in the 280 parts realm, during the height of the ice ages. The team used three independent temperature proxies obtained from a peat deposit at the Beaver Pond site on Ellesmere Island in Canada's high Arctic. So north latitude 78 degrees, west longitude 82 degrees. Ellesmere Island today is one of the coldest and driest places on Earth, with an ecosystem that includes ice sheets, permafrost, sparse vegetation, few mammals. Because the site is situated at such high latitude, it experiences darkness 6 months of the year. Contemporary temperatures can range from approximately minus 38 C in winter to 9 C in summer. Okay, that's average. It gets colder than that. During the Pliocene, however, this site was much warmer and more lush, featuring cedar trees, mosses, herbs, fish, frogs, and now extinct mammals that included tiny deer, ancient relatives of the black bear, three-toed horses, which were small ungulates, small beavers, rabbits, badgers, and shrews. So a little more diverse ecosystem. I'm not able to enlarge this, but here's a little reconstruction, an artistic rendition of the High Arctic beaver pond site, which is Strathcona Fjord on Ellesmere Island, as it may have appeared during the Pliocene. And the artist is George Rinaldino, was that Teichmann. And over here, the research is hard at work. So there's Ashley Ballantyne. Then we have Dara Finney in the middle, and Natalia Rubishinsky here on the right. So the beaver pond site was ideal for proxy studies because organic materials, for example, trees, plants, mosses, have been extremely well preserved in the peat deposit, allowing researchers to conduct detailed and high quality analyses. The team selected three independent proxies for Arctic terrestrial surface temperatures during the Pliocene. 1. Oxygen isotopes found in the cellulose of fossil trees and mosses in combination with annual growth ring in trees. 2. Vegetation composition when compared to the climate conditions of modern near relatives. And 3. The distribution of ancient membrane lipids found in soil bacteria known as tetraethers, which correlate to temperature. So these are the three proxy data that they examined and then considered in their analyses. The three independent temperature proxies yielded mean annual temperature estimates that were statistically indistinguishable from each other, giving the investigators strong confidence in their estimates of Pliocene temperatures. The team constructed a composite mean annual temperature estimate of minus 0.4 degrees C, suggesting that Arctic temperatures were 19.3 degrees C warmer during the Pliocene than they are today. That's a tad warm. These estimates were also 5 to 10 degrees C warmer than previous estimates derived from temperature proxies or climate models. I have more to say about all this in a moment. The Pliocene is particularly interesting when compared with other ancient intervals of warm global mean temperatures because Pliocene atmospheric CO2 levels are estimated to have been approximately 390 parts per million by volume, only slightly higher than pre-industrial levels. Okay, currently we're about 420, so you know. So according to Ballantyne, the findings indicate that global CO2 levels of approximately 400 parts per million by volume are sufficient to produce mean annual temperatures in the high Arctic of approximately 0 C. In other words, you're right at the freezing point of water. At this temperature, it is very difficult to form and sustain perennial ice, which so happens to be a defining feature of present Arctic environment. These findings suggest that current levels of atmospheric carbon dioxide may be high enough to bring about significant and irreversible shifts in the Arctic ecosystems. Let's highlight that. That's a very important statement. These findings suggest that current levels of atmospheric carbon dioxide may be high enough to bring about significant and irreversible shifts in Arctic ecosystems. Irreversible. What are we seeing nowadays, folks? Further investigations to estimate sea surface temperature and the extent of Arctic sea ice during the Pliocene would help calibrate the climate models that often underestimate Arctic temperatures during warm intervals. And the study is titled The Response of Polar Ecosystems to Enhanced Warming, a comparative study between modern boreal forests and Pliocene Arctic forests. So, What's the significance of this? Now, this is July 2010, 12 years ago. And at the time, saying that approximately 400 parts, a little more perhaps. And now in the 10 years, we have levels at what? 421? That's CO2. Factor in CO2 equivalent, i.e. methane, nitrous oxide, and other trace gases. And depending which study you look at, we're talking 570, 670 for the equivalent CO2 levels today. And what do we see happening in the Arctic? Everything is warming up rapidly. Everything is warming up rapidly. The permafrost is thawing. We're losing the sea ice. And now the permafrost in the seafloor is thawing. We're seeing what? We're seeing more rain than snow. And that's going to be a trend as this century progresses. This explains why, in my opinion, why the Arctic is warming 4 times faster than the rest of the planet. It could very well be that they are correct that it is changes in CO2, that the Arctic is much more sensitive than previously thought or considered. And we know that what happens in the Arctic does not stay in the Arctic. So when I got a little pushback from how can you say, warming of 5 to 11 C by 2100? Well, if other studies can confirm this and work with the sea ice can confirm this, this is a very good evidence to support such a projection. Now, it could very well be that there will be a gradient. For example, the tropics may warm by 5C, but the Arctic's warm by 11C. You might have a gradient from low to high latitudes. That remains to be seen. I won't be around. Humans probably go extinct this century anyway. But if this is correct, the planet's in a lot more trouble, at least for humans. And, of course, this could trigger, and is triggering, mass extinction events. We're seeing species loss every day. So this is, it goes to show you how there's a tendency to underestimate, underproject how bad things really are, or how bad they could really be. And I think part of the problem is not fully appreciating the exponential function. Because exponentiation alone will have this be on a runaway. So the Arctic is extremely sensitive to changes in CO2 levels that can rapidly warm it or cool it. And we're rapidly increasing CO2 levels, which means we're rapidly warming. We're warming the planet, but we're rapidly warming the Arctic, and we see it now. And as I said, what happens in the Arctic doesn't stay in the Arctic. We're seeing crazy weather now. We're seeing climate chaos. We're seeing it. It's happening now. Climate change is not something, it'll happen in 30, 50 years' time. No, it's happening right the hell now. So, draw down CO2, stop emitting, and we can stop this. Nope. We've already set it in motion. And as I've made the argument, in my view, the planet's already passed the tipping point back in the mid-1990s, when the oceans could no longer sequester the heat and CO2. So here's something else to mull about and think over. Talk soon. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.